before going into this detail what we are going to study today, let me revise a bit, and also I will ask you guys a few questions, how much you remember. Okay, so first of all, we started with 1D solids, and in after 1D solid there is only one question in 1D solid. What is that question that can come in 1D packing? Tell me guys, there's only one question that can come from 1D packing. What is that question?
What is the coordination number?
Yes, yeah, what is the coordination number of the atoms? And the answer is
2.
2. So in this chapter you have to remember each and everything. Okay, and because each and everything is in such a very flowy manner na, and that you can like 1D packing will lead you to 2D packing, 2D packing will lead you to 3D packing. Okay, so everything is very sequential, so you should remember everything. Then we went to 2D packing, and when we went from 1D packing to 2D packing, how many cases were there? How many cases? 2 cases. Okay, so what are those 2 cases?
AA type and AB type.
AA type and AB type. I will also write them as square close packing in 2D, and we have hexagonal close packing in 2D. Right? Yes or no?
Yes.
Okay. Now you guys tell me what is the packing efficiency of Salman. You will tell me what is the packing efficiency of square close packing. Yes, Salman. You're here, right? Salman. What happened? You can't unmute. Please send the answer in chat. Those who know, they can send the answer in chat, okay? But be fast. Oh, Salman is not here. Okay, fine. No problem. Okay. Khalid, you tell me what is the packing efficiency of square close packing? Yes, Khalid. What is the packing efficiency? Others can answer in chat. Others can answer in chat. Khalid, tell me what is the packing efficiency? नहीं याद है Khalid आपको? Yes, Maimuna, correct. Somewhat correct, I would say. Khalid, are you there? Okay, fine. It seems Khalid
Yes,
is not
sir. I
here.
got disconnected.
I'm asking what is the packing efficiency of square close packing?
Yeah, it's 78.5%.
78.5%. Okay, fine. Mazia, you will tell me what is the packing efficiency of hexagonal close packing in 2D?
So 74%.
74%. Maimuna, what is the answer?
90%.
Yeah, it is 90.6, 90.7. Okay, so you can write 90.6%. Right? 90.6%. Okay, Mazia, what happened? आप revise नहीं कर रहे हैं? Yes, Mazia.
No, sir. I'm revising, but I just got confused.
You got confused? Okay, no. Please revise this, okay, daily. Start studying daily. Now, from square close packing, we made 2 types of solids in 3D, right? From square close packing, we went to 3D packing, and in 3D packing, we had 2 cases. Now, I will write the unit cells for these 2 cases. The first unit cell was simple cubic. Second was the body centered, right? BCC. Now, okay, Mazia, you tell me what is the packing efficiency of simple cubic?
Read in R like A/2.
What is the packing efficiency? I'm asking you. आप पढ़ ही नहीं रहे. You're not studying, Mazia. When did you last read the notes, Mazia?
Sir, after class, last class.
After last class. So last class में क्या पढ़ा था आपने बताइए?
Do
you remember it?
No, sir.
No, sir. ऐसे नहीं चलेगा ना काम. See, you have to revise it twice. Okay, you have to revise it twice. Once is after class. Okay, and then Mazia, फिर कब revise करना रहता है आपको पता होगा, है ना? बताइए.
Before the next class. And
हाँ, before the next class, है ना? ठीक है. So ऐसे पूरा बिल्कुल आपका sandwich बन जाएगा. You will have revision here, you will have revision here, and the class will be here. Okay, so you will not forget anything. Okay, so please start revising. Even though if you have, even in school now, you can take the notebook and then just flip a few pages. Okay, just flip a few pages. बस एक बार देख लीजिए. At least see the photos and pictures. Okay, and you also, whenever you have these type of terms now, for example, last time we studied these things. So what you do, you highlight these parts. Packing efficiency ये होता है. Then उसके बाद you will highlight what is the relationship between 4R and A root 2. Okay, so these are the things that you have to do in your notes, so that whenever you are revising, you don't have to read the whole thing, you just read the conclusions. Because explanations and understanding जो है ना, आपको हर बार समझना नहीं पड़ेगा कि packing efficiency कैसे निकालते हैं. Okay, you don't have to do that. Once you have understood how to calculate the packing efficiency, then you must be interested only in the conclusions. Okay, only in the conclusion, that is packing efficiency 78.5, 90.6, and here the packing efficiency is, who will tell me, for simple cubic, what is the packing efficiency for simple cubic? Yeah, tell me.
52%.
Yeah, 52.4. इन्होंने पूरा होल नंबर याद करके रखा है मैमुना आपने. हाँ,
Yes.
yes मैमुना. हाँ, okay, fine. Even if you remember the whole number, it is okay. But अगर स्कूल में आए ना तो ये वो लोग डेसिमल पॉइंट्स में देंगे. ठीक है, just remember this point. And I hope they will not give you some options like this 52.1, 52.2. ऐसा कोई ऑप्शन नहीं देंगे जहाँ तक हमको उम्मीद है. But still, at least learn something. Whole number is also fine. Now in HCP we had two different cases. Okay, we had two different cases. There was upward triangle, there was downward triangle, and we kept on upward triangle, and then we had, and this triangle got converted into octahedral void, right? This converted into tetrahedral void. When we kept on octahedral void, we got ABC, ABC, if you can remember. And in this tetrahedral void, we got AB, AB packing. Okay, and ABC, ABC type, it has another name for this packing, that is cubic close packing. And the unit cell for cubic close packing is face-centered cubic. Now, who will tell me what is the packing efficiency of face-centered cubic? माजिया बताइए आप. याद है आपको? नहीं याद है, भूल गए.
So it's 74%.
हाँ, वो तो देख लिया आपने, अभी हमने दिखाया था 74%. Okay, fine. So today we'll be studying this ABAB type of, okay, this ABAB type. So let me go back here and copy these two things, paste it here. Okay. So now in this we have, this is the first layer, then we have the second layer, and we will put the second layer on the upward triangle voids, right? So we have put it here. Let me place it in a better way. Yeah, right. So I have got it somewhat. Okay, fine. Now I will place the atoms. I will place the atoms on the new voids that is created. What are the new voids? So you can see that the voids that are made by layer B. So I am pointing it by yellow. I don't think yellow is a good color. Let me take some different color, blue color. Okay. So this is the void, and I will be covering these voids, right? The void that is made by the new layer. Okay. And in order to cover these voids, what I will do, I will put up another layer. So let me put up another layer here. Okay, you are here now, Salman. Fine. Now, when I will put this another layer, okay, sorry. Let me put a fraction of this layer, not all. Okay, so I will be putting this layer, and you can see that as soon as I'm putting this black atoms on the voids that is made by the new layer. You can see that I have got the same A layer. So I have, this is the layer A. Then we have the red atoms as the layer B. Then again we have the third layer is again this dark, no, this dark one. We have two atoms of A here, right? This is again A. And again, if I will cover the void that is made by the A layer, I will get the B layer. So we are having AB type of packing, AB type of packing. So okay, fine. We have already seen this. So moving ahead, we will decide on the unit cell. So we have here AB type. Okay, AB type. And please remember here the base is HCP. Okay, the base is hexagonal close packing of 2D. Okay, the base is that one. AB type आपका BCC भी होता है, लेकिन उसको BCC की तरह याद रखिएगा. ठीक है, fine. AB type packing. So what are the atoms that I will be taking? So I will first of all take atoms from the first layer. So if I will take the atoms from the first layer, I will take the black atoms and I will take in this manner. Wait a second, let me. Okay, in this manner, I have taken the atoms of the first layer, that is the black layer. Please remember, I can take any set of atoms. Okay, now we will take the red atoms. These are the red atoms that I am taking. Okay, behind this layer, and then we will take the same A layer. So we have to complete the cycle. If I started with A, I have to end with A also. Okay, I have to also end it with A. So we have got the atoms here. Now we will join the midpoints and see what type of unit cell am I getting. Okay, so I have 6 black ones. 1, 2, 3. Okay, I will have to make it in such a way that the 3D, you can view the 3D diagram now. So I will make this a bit small. This will be far away. This will also be far away. Okay, fine. I will copy this, and same thing is present in here. So I will paste it here, and I will try to join it. Okay, fine. First of all, I need to get it aligned very nicely. I think it is fine. Now let me join these lines. Okay, and inside we have 3 red atoms. Let me highlight the black one even more so that we can understand. Okay, fine. So here we have the unit cell. Now, if you look at this unit cell is going to be, this unit cell is hexagonal unit cell. Okay, hexagonal unit cell. I have missed 2 atoms, that is this middle atom here and this middle atom here. Okay, now it is fine. Everything is there. Right. So this is what? This is a hexagonal close packing. Okay, in 3D. hexagonal closed packing in 3D. Okay, so in this, you don't have to derive the packing efficiency, but we will look at the Z. Okay, the first thing that we will look at is the Z. Okay, so what is the Z here? What is the Z here? So how many types of atom can you see in this case? First atoms here that you can see is the corner atoms, right? Then you can see that there is someone in the face center, this black one, these black one, and this black one is in the face, right? This is in the face center. And then you have in the body, inside body. Okay, these are the 3 red atoms. Yes or no? All of you can see the atoms. Tell me.
Yes, sir.
Now, this is not a cube. That is why the corner atom will have a different contribution, because it is being shared by a different group of unit cell, or a different group of rooms, you can say. So let us first of all see what is the contribution of the corner atoms in this case. So what you can do, you can make the other, so you elongate it here, okay, and then you can make one room like this and one room like this. So you can see that this one point, one corner, it is shared between, all of you can see na, ऐसे एक room बन जाएगा आपका और yes or no? All of you can see here.
Yes, sir.
Right. In one floor, the corner is shared by 3 rooms, right? The corner is shared by 3 rooms. So this is one room, this is the second room, and this is the third room, right? So in one floor. Now, similarly, there will be 3 rooms in that floor above, right? Yes or no? Tell me.
Yes, sir.
Right. So you have the corner atom, it is shared in 6 rooms, and hence the contribution of each will be what? 1 by 6. So contribution of the corner one is 1 by 6 into, how many are there in corner? We have 6 here and 6 here, that is 12. And this will be equal to how much? 2, right? So for the corner, it is equal to 2. The face center will be here also half, because this one face, it will be shared by the floor above. So you'll have half into, we have 2 face center atoms. This is the face center atom here, and this is the face center atom here. This will give me 1. And in the body, we have 3. So this will be giving me 3. If I add them all, the Z is equal to how much? 3 plus 1 plus 2, that is equal to 6, right?
Yes.
Sir, no? Okay, fine. Now we have the second point that you have to remember is the voids. Okay, so if you remember, the octahedral void is equal to how much? N, where N is the number of atoms, and number of atoms here it is equal to 6, and hence the number of void is equal to 6. Okay, please remember void in unit cell we are talking about. Okay, void in unit cell. So if I take, for example, 100 atoms, if I take 100 atoms and they are making HCP, that is making hexagonal closed packing in 3D, that means if I have 100 atoms, I will have 100 octahedral voids. Okay, but as of now, I am talking only in one unit cell. That is why I am telling that octahedral void is equal to 6 in one unit cell. Okay, please remember these points. Then we have the tetrahedral void, and it is equal to how much? 2n. That is equal to 6 into 2. That will be equal to 12. We have 12 tetrahedral voids and 6 octahedral void. If you don't remember how did we get n and 2n, let me remind you guys. Starting of last class, we had this conclusion that we had 2 tetrahedral voids and 1 octahedral voids, and hence both the packing ABAB type and ABABC type will have tetrahedral void double the number of octahedral voids. Okay, so let me go back here, and you have got the voids. Now next is the third is the packing efficiency. Now you don't have to derive this, because again, calculating the volume, have you learned the volume of this type of 3D hexagon? No. So that is why you don't have to derive this packing. The packing efficiency, it is equal to 74%. Okay, the packing efficiency, it is equal to 74%. Now there is one thing that you have to know, that is the this is known as the length A. There are 3 dimensions, so this will be A. Okay, this is known as A, and then you have B, and this height is the C. Okay, so it has 3 dimensions, A, B, and C. A, B, and C. Now, in this case, we have 3 different angles also. Okay, 3 different angles also. We have angle between A and B. We have angle between A and C, and then we will have angle between. Let me write the A. Wait a second. We write A and B here. This is B. This is A. Okay. So here we have angle between A and B. Here we have angle between B and C, and we have also angle between C and A. So those angles also have name. Okay. So let me write those names, and then so we have A, B, and C, right? These are the dimensions. These are the dimensions. So if you want to calculate the angle between, and we have the angles that are alpha, beta, and gamma. Okay. But please remember, what is the alpha and beta? So we have alpha, the angle between B and C. Okay, angle between B and C. Beta is the angle between A and C, and gamma is the angle between A and B. So you can see that this is the edge on the wall, and these are the floors. So you know that you have wall and floor, they have the angle that is equal to 90 degrees. So alpha, this will be equal to beta, and this will be equal to 90 degree, and the gamma here, it will be equal to 120 degree. Is that clear? Yes or no? Please tell me. Alpha,
sir.
beta, and gamma.
Sir, beta again, which angles? A and C?
हाँ, बीटा इज ए एंड सी.
Okay.
ठीक है, इसको छोड़ के बीटा, इसको छोड़ के इन दोनों का एंगल हो जाएगा. अगर आपको गामा देखना है तो इन दोनों को छोड़ दीजिए, ए बी का एंगल हो जाएगा. ठीक है. So what you have to do now, you have to write these things down and let me know when you're done. Salman is done, waiting for others. Just waiting for Khalid now. Please raise your hand if you're done. Khalid is not here. Fair. So everyone is done till here, and we have essentially made everything. We have got packing efficiency here also. Octahedral wide, tetrahedral wide we have also got, and we have also got the Z here. And here you don't need the relationship between A and R, okay? Because in this case, you have not only one unit dimension. In the cube, you had only A. Here you have A, B, and C. You don't need the relationship between A and R because we have not one dimension, so you have 3 dimensions, A, B, and C. Okay, fine. So let me just summarize here. Since we have got everything, let me take this. Okay, this is the chart that you will have to remember. Okay, coordination number is 2, and square close packing efficiency is this much. Okay, fine. So we will write this more clearly now. Okay, so here we have simple cubic. Here we have BCC. Here we have hexagonal, right? HCP in 3D. And here we have face-centered cubic, which is also known as CCP. The packing is known as cubic close packing. Okay. So for all of these, we have to know a few things, right? We have to know a few things. Let me also get some more area. So first of all, that we want to know is the Z. What is the Z for each of these cases? Then we will know the coordination number. अच्छा हाँ, इसमें coordination number छूट गया. Coordination number देख लेते हैं एक बार. Okay. Fine. So please, I want all of your attention here. Let us take this atom, that is the red atom. Sorry, that is the black atom here, this middle one. So in this layer, it is touching how many atoms? Can somebody tell me? The one that I have highlighted in blue. This atom is touching how many atoms?
6.
6 atoms. Okay, fine. Now, this atom is just beneath, is just under these 3 atoms, right? Yes or no?
Yes.
So that is why,
Yes,
and
sir.
they are making these 3 red atoms and this one black atom, they are also making a tetrahedral void, and that is why they all will be touching. So hence this black atom is touching this 3 red atoms, right? Yes or no?
Yes.
Okay. Similarly, we have here, this is our A layer, this is our B layer, and this is our again A layer. Then we will have another B layer, right? Yes or no? AB type now.
Yes.
Yes, sir.
Again, we will have these 3 red atoms in a similar way in the next B layer, and they will also be touching this black atom that is highlighted in blue color of A layer. Okay, so we can see that in the same layer we have 6 atoms that is touching, and in the above layer we have the 3 red atoms, and in the below layer we have the 3 red atoms, and hence the coordination number will be 12. Okay, the coordination number is equal to 12. The coordination number is equal to 12. Right. So in all of these simple cubic BCC, we'll also write the coordination number. Then after the coordination number, we will write the relationship between A and R. And after that, we'll write the packing efficiency. Then we'll write the voids. Okay, so tell me now. Please tell me, what is the Z for simple cubic? What is the Z for simple cubic? What is the Z for simple cubic, guys?
1.
1. Very good. And what is the coordination number? Yes, guys, tell me what is the coordination number? What is the coordination number?
8.
No. देख के बताइए कोऑर्डिनेशन नंबर. लिखा है ना हमने कोऑर्डिनेशन नंबर कि नहीं लिखा है? आई होप लिखा हो. जी
6.
6, right. So for simple cubic, the Z is equal to 1. Coordination number is 6. What is the relationship between A and R?
A is equal to 2R.
A is equal to 2R. Very good. What is the packing efficiency? वो तो लिखा ही हुआ है 52.2.4%. And the void is cubical void. Right? Yes or no?
Yes, sir.
Yes, sir.
Okay, fine. Now, moving on to BCC. What is the Z here for BCC? Body centered cubic.
Z is 2.
Z is 2. Coordination number. Coordination
Eight.
number is, yeah, here it is 8. And the relationship between A and R,
A is equal to 4 by root 3 R.
ऐसे याद कर लीजिए इसको, A root 3, that is the body diagonal, is equal to 4R, है ना? ठीक है, दोनों ध्यान रहेगा आपको. Like you will have A root 3, that is the body diagonal, and 4R because we have 3 atoms, but essentially we have 4 radiuses. And packing efficiency is equal to how much for BCC?
68.
68%, na?
Yeah.
And void is, okay, you don't have to remember the void, it is distorted octahedral void, but you don't have to remember the void, it is not there in your syllabus. Okay, now moving on to HCP, we have just seen that. What is the Z here in HCP? क्या लिखा है आप लोगों ने Z? हाँ?
4.
What? Okay, I need somebody else's answer also.
Sorry.
HCP in 3D ना, अभी क्या है हम लोगों ने? AB type.
6.
Z is equal to 6.
Yes. Okay. Hexagonal close packing in 3D is equal to 6. Okay. Coordination number is 12. We have seen relationship between A and R. You don't need that. Packing efficiency is 74%. And in this we have 6 octahedral void. We have 6 octahedral voids and 12 tetrahedral voids. For FCC, what is the Z? What is the Z for FCC? 4. Okay. Coordination number here is also 12. Relationship between A and R is A root 2 is equal to 4R. Packing efficiency here is also 74%. And the void is what? Here also we have 6 octahedral void and 12 tetrahedral voids. Okay, so please make this chart. Okay, please make this whole chart. And this is, so we have done how many classes till now? We have done 1, 2, 3, 4. Approximately 4 classes because abhi to ye wala baki hai kafi. So this is the conclusion of the 4 classes. Okay, and these are the things that you have to remember. Waiting for Khalid and Maimuna.
Done, sir.
Done. Okay, Maimuna is also done. Okay. So let us start with now a set of questions. Okay. So the questions, for example, calculate the packing efficiency. And what is the relationship between A and R? You will be given the radius, and you will be given the edge length, and you will be asked the radius. Okay. So these are the things that you will be given. So let us do a few questions. Let me take a few questions first of all. असाइनमेंट में ही दिया था हमें, वही वाला कुछ सवाल आपको देते हैं वेट इसके। Wait, did I send the assignment? Okay, so write this question. A metal crystallizes in FCC lattice. The edge length of unit cell is 408 picometer. The diameter of the metal atom is we have options 288 picometer, 144 picometer. The option is 408 picometer. The option is 204 picometer. Okay, write this question. Okay, I've got an answer. नहीं, कोई ऐसा ऑप्शन है नहीं ना खालिद, you have to tell me option A, B or C, A, B, C or D. Okay. What is the relationship? Who will tell me for FCC? The relationship between the edge length A and the radius.
A root 2 equal to 4R.
And this is R, right? Radius, and they have asked diameter. Okay. Please like focus on things carefully. You'll have to calculate the R, or rather you can say that this will be equal to A root 2 is equal to 2 into diameters, right? And now you can calculate. So diameter will be equal to how much? A root 2 divided by 2, correct? So this is rather A divided by root 2, which is equal to 408 divided by root 2. Hai 408 divided by root 2. So here you have 408. So obviously this is not an option. This is right. This is wrong. Okay. This can never be the answer. You have 408. What is the value of root 2? What is the value of root 2, guys?
1.4.
1.4. You can write 1.4. Or you can write it 1.4. You can also write 408 divided by 14. And here you will write into 10. Okay. Into 10. So now you can solve it. Solve it and tell me. Write the next question. Okay. Solve it. Those who are done. I think only Mamuna is done. बाकी लोगों ने पता नहीं क्यों नहीं जवाब दिया है. इसको करके बताइए कितना आ रहा है. This was asked in NEET 19. So 291.4 you are saying, Salman. So it is nearest answer will be A, है ना? Yes or no, Salman?
Yes, sir.
Okay. So this was asked in 19, okay? NEET exam. Write this one. See how small topics, na? You have just one relationship, and from there also you're getting questions. So each and every topic is important, okay? So you can't say that, sir, no, this topic is not important or that topic is not important. Each and every topic is important. चलिए इसमें बताइए. This is easier because you don't have to calculate. सीधा आपको रिलेशन डालना है तो पुट कर देना है इसमें.
Sir, what will be the answer again for the first question?
A 288.
Okay.
This question here, simple question. This was also asked in. This was, I think, in NEET 20. Okay, Mamuna, we will see. Let others answer, okay? Okay, Khalid. Done, guys? कर रहे हैं आप लोग अभी भी? माजिया, आपने एक भी नहीं जवाब दिया, क्या हुआ? Yes, Mazia. Mazia, are you there? Since Mazia is not here, what happened? Salman, आप भी नहीं है क्या?
I'm here. I'm here.
Okay, what happened? You did not answer.
A little bit slow calculation. Wait, I'll answer.
No, why slow? इसमें कुछ करना ही नहीं है. आप बताइए, what is the relationship between the body center cubic of the edge length and the radius? What is the relationship?
Root 3 by fourth one.
It is a root 3. It is equal to 4r. है ना?
Yeah.
So r will be equal to root 3 by 4 into a,
Yeah.
and a is 288. Okay, fine. Now we will look at a different type. There was also one more question in which that came in 21, NEET 2021. That was how many tetrahedral void and octahedral void are there in hexagonal close packing in 3D? Okay, so the answer was tetrahedral void is how much? 12. Octahedral void is how much? 6. Okay, in 1 unit cell they asked. Okay, so simple questions are asked here. You can easily answer them. Now let us move on to a bit more and a bit logical type of questions that you will see. That is this type of question, that is the formula questions. Okay, so you will be asked what is the formula of compound. This will be a common theme in these type of questions. So here they have told you that it's a cubic solid. Cubic means it is simple cubic. If they have not mentioned it is anything, so here we are seeing that it is cubic solid. It is made up of P and Q, and they have said that atoms of Q are at the corners. Okay, atoms of Q are at the corners, and then they have said that P atoms are at the body center. P atoms are at the body center. What is the formula of, and what is the coordination number of P and Q? Okay, fine, we can answer this later on, but let us first of all deal with this formula one. So this, for questions like this are very easy, but you need to follow the way that I am telling you guys. Okay, the way that I'm telling you guys. First of all, you will see they are saying that Q atoms are at the corner. So you'll write Q, then you will draw an arrow. Okay, please follow this method. You will not be getting wrong. Q in the corner. Okay, Q atoms are at the corners of the Q. Okay, then how many corners are there? There are 8 corners, and the contribution of each corner is how much? It is 1 by 8, and that is why it is equal to 1. And then you will circle this one. Then you will write P, and P is at the body center, right? It is in the body center. And hence, how many P will be there? There will be only one P, and its contribution will also be 1, and this is equal to 1. And then you will circle this. Then you will write P1, Q1, and you see that 1 and 1 is there. So you can just write the formula of this compound as PQ. Is this clear? Yes or no? Please tell me.
Yes, sir.
And also now we have to tell the coordination number. So you can see that it is a body centered because we have atoms in corner and atom at the body center. So what is the coordination number of P and Q? It is equal to 8, right? The coordination number will be equal to 8. I hope you have not, I think you don't remember these things now, but I ask you guys to please remember these values, okay? Coordination number of all the lattices and units. So please write this down. Then we will look at a bit more complex examples of this type of question, formula based questions. Write this down fast, okay? Then we'll look at some other type of questions. All of you understood, right?
Yes, sir.
Okay. Done now? Are you still writing? Still writing? Sorry. Yes or no? Please tell us something.
Done, sir.
So raise your hand now. Guys, what happened? Okay. Now please look at this question. Don't write anything. Okay. In face-centered cubic lattice, atom A occupies the corner position. Okay. So first of all, you will write A, and then you will mark it corner. Corner position. And atoms of B occupy face center positions. Occupy face center position. Okay. So we have atom A that is occupying corner. So once you have done with this corner, you will write there are 8 corners and its contribution is 1 by 8, and hence it is equal to 1. And then you will circle this one. Atoms of B occupies the face center. Okay, fine. B occupies the face center. What is the contribution? And okay, fine. First of all, how many face center are there? How many faces are there and how many face center atoms can be there? Tell me. How many? Khalid, Maimuna, Mazia, Salman, what happened, guys? अभी तो जल्दी जल्दी आंसर करना चाहिए आप लोगों को. How many face center are there? How many faces are there in a cube?
6.
6, na? Okay, fine. So we have 6 atoms of B. They occupy the face center position. That means they are in the faces, the center of faces. We have 6 faces. Next statement says that if one atom of B is missing from one of the face centered points. Okay. So how many atoms? We have 6 face centers and one atom is missing. So 6 minus 1, that is equal to 5, right? And its contribution. What is the contribution of face center atoms? What is the contribution of phase center atom?
1.
यही तो है, आप लोगों को यही तो याद करके रखना है. Look and tell me. Look and tell me what is the contribution of phase center atoms. What is the contribution of phase center atoms? Phase center cubic में
1 by
जाइए.
2.
Yes, ma'am. Wanna tell me?
1 by 2.
1 by 2. Right. Please remember these points. Okay. Phase center 1 by 2. Corner. Corner is how much? What is the contribution of corner atoms? याद कीजिए भाई.
1 by 8.
पढ़ाई चालू कीजिए आप लोग. पढ़ाई चालू कीजिए. Okay. Then you have H center also. Okay. H center is 1 by 4. H center is 1 by 4. So please remember these values. Okay. So this will be equal to how much? This will be equal to 5 by 2. Okay. Then also circle this one. Then you will write it like this: A 1 and B 5 by 2. Okay. Then what you will do? You will multiply 2 on both the sides. You will get A, because this is a ratio, right? We have for each A, we have 5 by 2 B's. So you will write here 2A, and in B also, if you multiply 5 by 2 into 2, what you will get? You will get A2 B5. Is that understood? Yes or no? Please tell me.
Yes, sir.
Okay. Please remember the steps. First of all, you identify the atom, the position, how many atoms are there, then the contribution, then you will get one number, circle it. Next atom, position, number of atoms, then you will write the contribution of each atom, then you will get one number, and then you have to, then what you have to do, you have to make them in a whole number ratio. Okay, you have to make them in a whole number ratio. You will never see a formula in which you have A, B 5 by 2. So you have to make it in a whole number ratio. Please write this down. I will give you one more question. Okay, so write this. After you are done, you will calculate this one. Okay. Next question is this one. Okay, so you guys solve these two questions. Okay, and I will be back in 15 minutes. I'm going to have my iftar and pre-maghrib. Okay, chalo. Please don't leave the class. Last time I think somebody left the class. Don't leave the class. Okay, do these two questions.
Okay, sir.
Okay. I have got answer from Maimuna and Salman. What about others, huh? Okay. Am I audible, guys?
Yes, sir. Yes, sir.
Okay. I have
Only,
got two answers.
only three of us are here, so
Yeah, okay. Khalid gave me another answer. Okay. Mazia, are you there?
Mazia is
Mazia?
not here.
Mazia
She's
नहीं है
not in the
लगता है.
meeting.
Not here. She left, I think. Fine. So let us start with the first one. Compound formed by elements A and B has a cubic structure in which A atoms are present at the corners of the cube and B atoms are at the face center. So it is quite simple. A is present in the corner. Then how many atoms will be there of A? 8 atoms, right?
Yes.
Into what is the contribution of each?
1/8.
1 by 8.
8. Yeah. So this will be equal to 1. Then we have B is present in the face center. What is the how many face centers? 6
6.
into
1/2.
1/2. So this will give me 3. So you'll have 1 and 3. You'll write A, B, 3. So this is already in the whole number ratio. You don't have to do anything else. Now, next one. Here we have ABC. Here they are saying A, B, C crystallized in cubic solid lattice with atoms of A at the corner. So we have A at the corner. Then B atoms are at the cube centers and C atoms are at the, okay, B atom is in the cube center, right? So that means body center, right? So what is the body? Our body is the cube and it is in the center. So we have body center. And then we have C atoms and C atoms are at the center of the faces. So this is face center. Okay. Then write the formula of the compound. So corner 8 into 1/8. This will give me 1. Body center is 1. So this will give me 1. Face center is 6 into 1/2. That will give me 3. So we have, so these are the numbers that you have to focus on. You have A1, B1, C3. So you can write A, B, C3. Okay, A, B, C3. Now, let us move on to a different type of question. And these are the questions that are more important, I would say. So let me see if I can find a few of them. Okay, there is one question that I think it is good. Similar type, but in that we have edge center. So let us discuss this fast and then move on to a different type of question. So these are the question in which you have been already given what are the, position of the atoms. Okay, so a crystalline solid has a cubic structure in which tungsten atoms are located at the cube corners of unit cell. Oxygen atoms are at the cube edges and sodium atoms are at the center. Sodium atom is where? Sodium atom is in the center. And then we have oxygen atom in the edges. So we have, first of all, tungsten, that is W. So W is in the corner. So this will be 1/8 into, sorry, let me write it a consistent way. That is 8 into 1/8. It will be equal to 1. Followed by oxygen atoms. It is present in the edges. Right? And how many edges are there? Tell me. In a cube, how many edges? 12 edges. What is the contribution of each edge?
1/4.
1/4. Yeah. So this will be equal to 3. Then we have the sodium atom Na. It is present in the center. So this will be obviously body center if they are not seeing anything. This will be equal to 1. This is equal to 1. And hence you have WO3 and then you have Na. Okay. W, there is O3 and then you have Na. And you know that we always write the metal first. So you'll write it like this, Na. And then what you will write? You will write WO3.
WO3.
NaWO3. Okay. So now moving on to a different type of question in which you will not be given the positions. Okay. You will not be given the exact positions. So, okay. Huh. This is one of the questions. So in this question, what they are saying, what is the formula of a compound in which element of P form HCP lattice? Okay, now you guys tell me, this HCP is what? We have learned two HCP, 2D and 3D, right? So which HCP is this, 2D or 3D?
3D.
What do you think, Salman? Which HCP is this? 2D or 3D?
3D.
3D. Okay. What about you, Maimuna? What do you think?
3.
3D, na? Okay, fine. So if there is no context given, that means it is going to be 3D because our whole real world, it is in 3D, right? So if they want to specify about 2D, they will tell you that it is 2D. If they have not specified, that means they mean it is 3D. So element of P, it forms HCP lattice. Okay, it forms HCP lattice. And atoms of Q occupy the 2/3 of octahedral voids. Atoms of Q occupy the 2/3 of octahedral voids. Now, in this case, you can see that they have not given a specific position of the atoms. They are saying that it is forming a lattice and it is present in the octahedral void. So in this type of question, what you have to do, you will write P, and then you will say that it is HCP lattice. Now, what is the Z of HCP lattice? How many atoms are there in HCP lattice? 3D. We have done it today now.
6.
6. Very good. Okay. So this is the number that you want to focus on, and you will circle it. Then what you will write? Then you will write Q, and Q, where it is present in the 2/3 of octahedral voids. And then you will just write this in numbers. You will write 2/3, and you remember, right? Word mass. In that we have a bracket of division, multiplication, addition, and subtraction. Of means what? It is another word for multiplication, right? So 2/3 of octahedral voids, it means 2/3 into octahedral voids. How many octahedral voids are there
6.
in HCP? 6.
6.
So this will be equal to how much?
4.
So this is the number that you want to focus on. You will write P6 and Q4. But you can see that we can further simplify this, and we can write this P3 and Q2. Yes or no?
Yes.
Yes, sir.
Understood? Yes or no?
Yes.
Well,
Can
is
I
it
give you a question?
necessary to like simplify it,
Yes,
or
yes,
we
yes,
can
yes,
just
yes.
put the answer?
No. You have to simplify it, okay?
Okay.
You have to simplify it, okay? Fine. Okay, so let me give you another question. Okay, write this one. Write this one first. लिख लिया तो बताइएगा जल्दी, हाँ? Please let me know if you are done, okay? Khalid, Maimuna, Salman.
Done, sir.
Write this question then. अब सिर्फ सवाल ही सवाल रहेगा, okay? We are done with so much of theory. इतने दिन से कोई सवाल नहीं था. Now you will only get questions. Okay.
The chapter
This
is
is
done.
very important. No, chapter is not done. There are a few
Okay.
portions that is left. Okay, there are a few portions that is left. But I can say majority of the chapter is done. Okay. What is the unit cell of CCP? What is the unit cell of CCP?
$12.
What is the unit cell? Unit cell. Unit cell क्या होता है इसका? FCC होता है ना?
Yeah, FCC.
Okay. एक
FCC.
चीज ना हमको लगता है I think I have written it wrongly about here. This is not right. We will have the Z is equal to 4 na, so this will be 4 octahedral voids and 8 tetrahedral voids, है ना? You correct this one. Just remembered it now. Okay. This FCC is Z is equal to 4 and hence octahedral void is equal to n, which is equal to 4, and tetrahedral void will be 2 and that is equal to 8. Okay. Tell me.
Sir, once again go to the chart.
Okay. Okay, fine. हाँ. ये ब्लैक कलर में जाए वो करेक्शन करना आपको.
Yes, sir. Done.
Done. इसको कीजिए. Yeah, got one answer. Yes, ma'am, gonna correct. Salman, try again. Salman, try again. अरे what you guys are doing, हाँ? चलिए खालिद बताइए. Y makes CCP. That means क्या होगा? Y will be making FCC ना? What is the Z for FCC? Khalid?
4.
Then atom element X occupy all the octahedral voids. All the octahedral voids, na? How many octahedral voids are there?
4.
4. So X4, Y4. You will get XY. Right? Yes or no? How is tell me?
Yes, sir.
Okay.
Yes, sir.
Now let us do one more question and then we will be done this class. I think similar question that we did. Let us leave. Wait. Let us leave this one. ये नहीं करते हैं. Let us see this. P forms CCP, है ना? So P is going to form what? CCP. That means it is FCC. What is the Z for FCC? It is equal to 4. And Q, it occupies 2/3 of tetrahedral voids, right? That means 2 by 3 into number of tetrahedral voids is 2, and that means 8, right? So this will be equal to how much? 16 by 3. है ना? Right? Okay, so we have 16 by 3 and we have 4. So P is 4 and Q is 16 by 3. So I will simplify this as P 12 and Q 16. है ना? If I multiply 3 on both sides, then further I can simplify it to how much? I will divide both of them with 4. है ना? I can divide both of them with 4, right?
P3 6 4.
Q4.
So, yeah, Q4.
है ना? Q4. चलो, fine. चलो. That is it for today.